So now we come back to another problem that we had seen earlier, but in the absence of friction. In this one, there is friction. Okay, the coefficient of static and kinetic frictions are given, and we're going to ask first again whether the system will move, and the second, if it does move, let's find the acceleration. So let's understand what's going on in the problem. Okay, you see that the force that is responsible for making the system move is that due to the weight of the 10 kg block. Okay, so it's a 98 Newton force that is trying to move the entire system. Okay, now we need to ask what force, if any, is trying to hold the system back. Now, in the absence of friction, nothing would be trying to hold it back. But because there is friction, okay, we know that friction will try to hold the system back because the only possible direction of motion is for the 10 to go down and the 15 to go to the right. Okay, if there is any motion. If nothing's moving, then the 15 stays where it is and the 10 stays where it is. Okay, now please make sure that you understand that just because the 15 is heavy doesn't mean it's going to start moving to the left. Okay, that's not going to happen. So what we need to do in the problem is figure out the force, the maximum static force of friction. We know the driving force. We know the driving force is equal to 98 newtons, which is the force on the hanging block. We need to figure out a maximum, force of static friction for the 15 kg block, which would be equal to mu s times Fn. Okay, and in the problem, if you understand, okay, you realize that in the vertical direction for the 15 kg block, we have 147 newtons pushing it down, and then we have Fn pushing it up, and therefore Fn is simply equal to 147 newtons. So we have 0.5 multiplied by 147 newtons, okay, which happens to be equal to 73.5 newtons. So since the driving force is greater than Fs max, Fs max is less than the driving force, okay, we realize that the system will move. System will accelerate. Okay, now that we know this, okay, now of course we need to make sure that we realize that we account for the force of the friction that we use now is going to be the force of kinetic friction. So while we're doing this, we can figure out, let's draw the free body diagram for the two blocks. Okay, for the 10 kg block, I have 98 newtons pushing it down, I have T pushing it up, and the result is 10 times A. For the 15 kg block, we have T pushing it to the right, okay, we have 147 pushing it down, we have Fn pushing it up, and we have mu k Fn pushing it. The only reason I write mu k Fn here because I know that the system is going to accelerate, and then I can write 15 times A pointing to the right. Now we already know Fn, but I'm just going to write down once again Fn is equal to 147 newtons. So therefore mu k Fn is equal to 0.4 multiplied by 147, okay, and which is going to be equal to 6 times 9.8, which is okay. So now we are ready with our equations. Okay, from the free body diagrams we see that 98 minus T is equal to 10A, and then T minus 58.8 is equal to 15 times A. Alright, once again we have a minus T and a plus T. We can add up our equations. We get 98 minus T plus T minus 58.8 is equal to 10A plus 15A, and this ends up giving me 98 minus 58.8, which happens to be 39.2 equals 25A, and so therefore A is 39.2 divided by 25, which ends up giving me 1.568 meters per second square. Okay, so understand the process in this problem. Once again, we had to figure out whether it was going to move or no, and for that I had to figure out Fs max, and once I knew it was going to move, I had to take Fk into account. Okay, so that's that problem.